Hey everybody, welcome back. If you grab your 7-2 notes, we'll get started. Now this section is really just looking at end behavior, what the signs do to the end behavior. You know, if it's even and positive, how do the ends go? If it's odd and positive, how do the ends go? So this is really about end behavior in terms of writing it, looking at it, understanding it. So we're going to go through this many times. So we're going to start with x squared and x to the fourth. And they ask you to graph them both. Now we have pretty good grids here which allow for some differences. So if I'm going to graph y equals x squared, so we have 0, 0. Let's see, that would be, this counts by ones left and right. It counts by fours going up. So if I do 2, 4, so x squared negative 2, 4. We could even go 4, 16 and negative 4, 16. It's kind of important to get the width right so you can see what's happening. So this is y equals x squared. And then I'm going to graph x to the fourth, which we're going to have to graph fewer points. So we go to here, and then 2 will go to 16. So we only have 2 and negative 2, 16. So you can see, and if you have not seen them both graphed before like this, you can see that x to the fourth is really a lot narrower. We're also going to graph if it has a negative in front of it, which you know, it just causes it to reflect over the x-axis. So negative 2, negative 4, 2, negative 4. We kind of already know what's happening. This is x squared, and then x to the fourth, 0, 0, negative 2, 6. All right, so there we go. So we have all the graphs. And then we're just going to be asked to read the graph. What is the domain? For all four of these graphs, the domain is the same. It's all reals. You can write it that way, this way, this way. Describe the symmetry. Well, all four of these are even, so they have the same symmetry. They are symmetric with the y-axis. What are the zeros? They all have the same 0 in that they all touch the x-axis in the same spot. So you can see why they lump these together, because we have a lot of the same answers. Now, this is where it starts to change. The range. If A is positive, we get a different range than if A is negative. So I'm going to make two little columns, and I'm going to do that for the rest of these as well. So if A is positive, then the range is y is greater than or equal to 0. You can write 0 to infinity if you'd rather. And if A is negative, this is y is less than or equal to 0, or you could write negative infinity to 0 that way. Now just due to space, I'm going to lose my graphs here. But again, we're going to stick with making two columns. So again, how does the sign affect the end behavior? Now this is super important, something that you're going to have to be able to do without the calculator. We have A is positive and we have A is negative. So if A is positive, as x goes to infinity, we're looking at the end behavior now, the arrows on the end. So if x goes to the right, y goes up. And if x goes to the left to negative infinity, y still goes up to positive infinity. But if it's negative, so again our end behavior starts with as x approaches infinity, x approaches negative infinity, and your response is what's y doing. You can see both ends point down, which would be negative infinity. So again, even and negative, both ends go down. Even and positive, both ends go up. Now they want to talk about increasing and decreasing. Now increasing and decreasing are not the arrows. Increasing and decreasing are the middle sections. This is a tendency to get people messed up because you want to look at the arrows. So if we draw this real quick, I don't know if I'll be able to erase it, but if we draw this real quick, don't look at the arrows, you look at the section, and we read from left to right. So as this goes this way, this is decrease. This looks like it's going up. As you go from left to right, this is increase. It's not about what the ends are doing, it's about what the graph. So downhill, uphill. This is increase, decrease, increase, decrease. This is a big, important idea for what we're doing the rest of the year and for calculus. Increasing and decreasing. So to write this, if A is positive, so we're looking at the one on the left, the graph on the left, it increases as x is greater than 0. It decreases where x is less than 0. Now, at 0, we've already addressed that point. At 0, it's kind of at rest. That's where it touches, it changes direction. So we're not going to address right at 0. And yes, you have to write increases and decreases. So for negative, if we're looking at the ones that point down, it increases where x is less than 0, or to the left as x goes to the left. And it decreases if we look at this from 0 out to the right, x is going up as x is greater than 0. Now, even functions, although they're the easiest to kind of graph and understand, they have the most detail. So that's the most that we're going to do for any of the rest of these, in case you're worried that this is going to take forever. So now they want you to graph these two things just on the same screen on your calculator. So we have x to the 1/2, and we have x to the 1/3. They may not look exactly like that, but this is sort of close. So we can see that. So the domain of x to the 1/2. Well, x to the 1/2 is this graph. And it goes from 0 to infinity, or x is greater than or equal to 0. But x to the 1/3 is this graph. And this has the domain of all reals. Now they want you to write each equation in radical form. Whenever you have an exponent, that's a fraction, it is power over root. So this is x to the first power, second root. X to the first power, third root. So we're just looking at square root and cube root graphs. That's all those are. How does the radical forms help you explain the difference in the domains? Well, in this domain, we don't have anything negative, right? So this domain, square root, it stops at 0. It's because you can't take the square root, well, you can't take the even root, whether it's 4th, 6th, or whatever, even root of a negative number. Well, you can, but you get an imaginary, and you can't graph imaginary, so therefore, we're dealing with graphing right now, so we're going to just say, we don't have a place for graphing imaginaries. Now we're going to do these odd functions. Odd functions are harder to graph, but easier to explain because they have less parts. So let's start with x to the 3rd, the parent function that you know so well. So we'd go 1, 1. 2 to the 3rd is 8. Oh, that's probably not 1. Forgot my scale. I'm going to skip 1, 1 and go to 2 to the 3rd, which is 8, because this is going up and down 8 now. So there is y equals x to the 3rd. So I got a bump here. This is y equals x to the 3rd. And then y equals x to the 5th. It's going to be tighter. 2 to the 5th is 32. Still goes through 0, 0. If you look at your calculator, the calculator does this, and it kind of has this awkward pause right here on the 0, or it kind of just sticks to the 0 a little bit too long. It doesn't mean anything. It's kind of sliding through there. It doesn't mean there's more than one x-intercept. It's just a good indicator that it's making a slide, because it has the same root 3 times, or 5 times, I guess I should say. So we have y equals x to the 5th. Then if we flip this over and do the negative, we still have 0, 0. We would have negative 2, positive 8, and positive 2, negative 8. And then for the negative x to the 3rd, we'd have negative 2, 32, and 2, negative 32. So the ends are doing crazy things. They're not together. They are opposite of each other. Now what's nice about this is the domain for all of this is all reals. They don't ask you this, but they will eventually, so I'm going to start it here. What's the range for all of these? Well, it goes negative, it goes all the way down to all the way up, so this is also all reals. Describe the symmetry. This is all has rotational symmetry because they're odd, so it's origin. All the zeros are the same, x equals 0. How does the sign affect the range? Well, it doesn't. The range is all reals, no matter if it's positive or negative. So then we get into end behavior. And again, super important. There's 4 types of end behaviors you have to know. The ones on the front, positive and negative even, and the ones right here, positive and negative odd. You have to just know these. So if A is negative, Oops, let's do A as positive. Let's make this positive. And then A negative, so that it lines up with our pictures. Again, you start the same way. X goes to infinity, X goes to negative infinity. X goes to infinity, X goes to negative infinity. That's the process for end behavior. Then you respond with what is Y doing. Well, as X goes to the right, Y is going up. And as X goes to the left, Y is going to negative infinity. So they're opposites. They're opposites of each other, but they match. X goes to infinity, Y goes to infinity, they match, but the answers are opposites. So there's lots of ways to look at that. Now, if it's negative, then the question and the answer are opposite. So if X goes to infinity, Y goes to negative infinity, and if X goes to negative infinity, Y goes to infinity. Increasing and decreasing? Well, if it's positive, it's always increasing. This thing never turns around. It looks like it's going uphill all the time. Even when it crosses the x-axis, even on the fifth, where it has that awkward pause, it's still increasing. It's slight, but it's still increasing. So if A is negative, it's always decreasing. Now, for those of you in regular pre-calc, you can stop the video here. The rest is for honors only. All right, so now we're going to talk about rational functions. As you know, y equals x to the negative first is the same thing as y equals 1 over x. And we don't know too much about this graph, but we're going to draw it. Just a quick sketch. We can't graph it super detailed. It has two asymptotes, one on the y-axis, one on the x-axis. And the other parts of the graph are called branches. And the branches, when we go to graph these, we're really never going to graph them too detailed. But we know we have a branch in the upper right and a branch in the lower left. Now, the important part about the asymptotes is that you draw the graph so that it obeys the asymptote. The asymptote is a guideline that the graph should not touch or cross. So if you're going to draw your graph and put your asymptotes and then just sort of draw it like that, that's really not going to be very good. So take your time, draw it in there, use the asymptotes for what they are intended as guidelines. Now, the domain for this is that x cannot equal 0. As you can see, as we look at this from left to right, it jumps over where x equals 0. The asymptotes are two lines at x equals 0, y equals 0. You could call this the y-axis and the x-axis if you'd rather. If you're not comfortable with writing equations, you're more than welcome to do it that way. Now, the end behavior. This is where it gets a little bit weird because we have 4 ends. So the ends that you're good at are the ones that go x goes to infinity and x goes to negative infinity. That's these two. As we look at it, going out from the center out. So as x goes to infinity, y has a boundary. Doesn't go very low. Y approaches 0. Now, every number has two sides. If we think about it like on a number line, I can approach 0 from the positive side, from where I came from, all the positive numbers. I can approach 0 from the negative side. It works this way too, where I think of 0, here's my negative numbers. I can approach it from the bottom, which would be from the negative. I can approach it from the top, which would be the positive. So we have to get kind of specific. We can't just say that it approaches 0. It approaches 0 from the top or from all the positive numbers. And as we go to negative infinity, if we trace this out, it does approach 0 again, but y approaches 0 from the bottom, or the negative side. Now the other two ends. This one is a little bit strange. So as we trace this graph, we're tracing it in. X is not approaching infinity. It stops. And that's why you have to identify the asymptotes. So as x approaches 0 from the right side, or from the positive side, now y is going straight up into infinity. X approaches 0 from the left side, that's this guy, coming from the left, coming from the negative side, then we go to negative infinity. Now, this is something we will spend a great deal of time on when we get into rational functions. It's just something we wanted to show you right now because it fits in with end behavior. So those have 4 ends, and that's how you describe it.